Okay, in this presentation we're going to look at the binomial distribution question. There's also an element of independent events in this, so we'll see how it goes. Consider 12 independent insurance policies numbered 1, 2, 3 all the way up to 12 for which a maximum of one claim can occur. Now just think about that for a second. That means we could either have 0 claims or 1 claim. So it's essentially a binomial trial here, okay? So for each policy, the probability of a claim is 0.1. Now, find the probability that no claim arises on the group of policies numbered 1 to 6, okay, and then exactly 1 on the group of policies numbered 7 to 12. Okay, so essentially what we have here is we have a set of 6 policies, okay, 1 to 6 and 7 to 12, and we want to find out the probability of exactly 1 claim or 0 claims, and we have a sample size here, a number of n independent trials. Here n is equal to 6 in both cases, and a probability of success. So essentially what we have here is a binomial random variable, okay, n equals 6 and p equals 0.1. Okay, so we have 2 sets. So essentially what we're going to do is run this calculation twice for both sets, 1 to 6 and then 7 to 12. Now I'm just going to sort of put this up here. This is essentially the theory. It's essentially just lecture notes here. Sorry, just as a quick remark, my typesetting skills have let me down there. So should that be n factorial? Okay, I don't know why it does this. It doesn't like factorials or exclamation marks. Anyway, so this is the formula we're going to use here, okay? And so this is the binomial mass function, essentially. Okay, so you can just have a read of that there just to see if it fits, and it does fit. So, and also binomial coefficients there, if you're not practiced with them already, get a bit of practice in, okay? So we have 2 sets of independent experiments, so 1 to 6 and then 7 to 12. And in each case, they are comprised of 6 Bernoulli trials here, so n is equal to 6, okay? And so the probability of success there is 0.1. I've sort of really talked about that already there, okay? So for the first set, we need to find the probability of x equal to 0, and for the second set, we need to find the probability of x equal to 1. And the question asks us to find the probability that no claim arises on the first set and 1 claim arises on the second set. Okay, so the question here is, this is the overall question here, find the probability of x equal to 0 times the probability of x equal to 1. Okay, so this is corresponding to the first set, 1 to 6, and the second set, 7 to 12. Okay, so essentially weaving in an independent events question. Okay, so essentially what we're going to do is use that probability formula that we have, or the binomial formula that we have. 6 choose 0, that's actually equal to 1. So that's 6 factorial divided by 6 factorial over 0 factorial. Or actually, I should have put it the other way around. 0 factorial divided by 6 factorial. Anyway, 0 factorial is equal to 1. And 6 factorial divided by 6 factorial, that's also equal to 1. So it just resolves into 1. 0.1 to the power of 0, that's 1. And so we'll end up with this, 0.5314. That is 0.9 to the power of 6. Okay? That's the 1 minus p, which is the probability of a failure. And this, or like, no claims. Okay? So 0.5314 is the answer there to that first part there. So 1 claim on 6 policies. So this is referencing the policy set 7 to 12. So the probability x equal to 1. 6 choose 1. That's 6 factorial divided by 5 factorial times 1 factorial. Or 1 factorial times 5 factorial. Doesn't really matter. We can express 6 factorial as 6 times 5 factorial. And what happens there is that the 5 factorials there can cancel out. So we end up with just 6 there. 0.1 to the power of 1, I should have put that in there, 0.1 to the power of 1, times 0.9 to the power of 5, which is 0.9505. So working that out, we should get 0.3543. So overall, the probability that we're looking for here is the multiple of the two, 0.5314 times 0.3543, and we should get 0.188. That's it there. So what was the trick of that question? What do we have to look out for? Essentially just recognizing it as a binomial distribution. No, it's sort of obviously when you're told that the name of the video, binomial distribution, but it's essentially building up the skill set to recognize that. What is a success? What's a failure? Bernoulli trials. Just reading the question and being able to see that. So that's grand. We'll leave it there.